Hello, and welcome to a new episode of History Pot. Today, we're not just going to tell a story, we're diving into a strange and thrilling adventure to discover how the Earth we live on came to be from scratch. We'll talk about a crazy idea that changed how we see this planet today. We're going on a long journey, from when the Earth was a terrifying fireball to becoming the cozy home we live in now. Get ready, take a deep breath, and let's travel back in time. All right, let's go back in time about 4.5 billion years. Back then, Earth didn't look anything like what we know today. It was like a giant fireball full of molten rock, toxic gases, and insane heat. Picture a planet where lava was erupting everywhere, with an atmosphere packed with water vapor and carbon dioxide, and not a single drop of oxygen to breathe. If anyone saw Earth back then, they'd say, "This isn't a planet. It's a massive oven with no door." I mean, if you were alive back then, you could have fried an egg on any rock without needing a pan, and maybe even melted butter next to it from the heat. But of course, there were no eggs or butter because there was no life at all. Over time, Earth started to cool down bit by bit. The molten rocks that were like lava began to solidify and form a thin crust over the planet's surface, kind of like the skin that forms on milk when you heat it. But beneath that crust, there was still a hot, sticky layer called the mantle. The mantle isn't liquid like water. It's more like hot honey. It moves very slowly because of the heat deep inside Earth. And that's what's going to be super important in our story later. The mantle isn't just one uniform layer. It's divided into two main parts: the upper mantle, which is stickier and moves slowly, and the lower mantle, which is more fluid and deeper. The movement in the mantle happens because of thermal currents. Hot rocks from below rise up because they're lighter, and when they cool, they sink back down. It's just like water when it boils in a pot and makes bubbles. This movement pushes everything above it, and we'll see its impact more in the next part. Okay, now imagine a weird idea. The continents we live on aren't nailed to the Earth. They move. This idea was almost unthinkable for scientists back in the day, until a guy named Alfred Wegener showed up in the early 20th century. Wegener was a meteorologist, meaning his main job was tracking clouds and rain. But he had another hobby. He was obsessed with geology and loved thinking about the Earth. One day, while looking at a world map, which back then was just a simple drawing, he noticed something odd. The east coast of South America and the west coast of Africa fit together like two puzzle pieces. Wegener thought to himself, "It can't be a coincidence that they match like that. These two continents must have been stuck together at some point and then drifted apart." The problem was, he didn't have solid proof to convince people. So he started digging for anything that could back him up. He found that fossils of the same animals and plants existed on both continents. For example, there was a dinosaur called Mesosaurus that lived in fresh water millions of years ago. Scientists found it in both Africa and South America, but the Atlantic Ocean between them now is way too wide. There's no way that dinosaur could have swum that distance. So the continents must have been connected at some point. Imagine the continents as twin siblings who got separated at a train station when they were kids. But when they grew up, they still remembered each other by their looks and even how they talk. It's the same deal with those fossils. Wegener wrote all his ideas in a book he published in 1915, saying that all the continents were once part of a single giant continent called Pangaea, which means all Earth in Greek. Pangaea was surrounded by a massive ocean called Panthalassa, meaning all seas. Over time, Pangaea started to break apart, and the continents began drifting away from each other, like plates sliding on a smooth, oily table, until they reached the layout we see on maps today. But back in Wegener's time, scientists weren't convinced at all. They told him, "Nice story, but how do the continents move? What's pushing them?" Wegener didn't have a clear answer because he didn't know about the mantle or plate tectonics like we do now. He suggested the continents moved like ships in the ocean, but he couldn't explain the force driving them. So a lot of scientists laughed at his idea, saying it was just science fiction, not reality. But Wegener was determined, and he had a gut feeling that the truth would come out someday. After Wegener passed away in 1930, scientists started discovering new things that changed the game. In the 1950s and 60s, when they began exploring the ocean floors with advanced equipment, they found something weird. There were long mountain ranges under the water, like the ones in the middle of the Atlantic Ocean. That was a shock, because people thought the ocean floor was just a big, flat plain with no features. Imagine you're watching a great movie, and suddenly you find out there's another part of the story hidden under the carpet in your living room. That's exactly how scientists felt when they saw those mountains. Scientists discovered that the floor of the Atlantic Ocean is slowly spreading, meaning new rocks are coming up from inside the Earth in that area, pushing the continents farther apart. And that's not all. When they studied the magnetism in those rocks, they found something wild. The Earth switches its magnetic polarity every long period of time, meaning the North and South poles flip. This movement gets recorded in the rocks, like an old cassette tape, proving that the continents were actually moving apart over time. In the 1960s, scientists put all this information together and developed a new theory called plate tectonics. This theory says the Earth's crust isn't one solid piece. It's divided into large plates, like pieces of a giant mosaic. These plates float on the sticky mantle, and they move because of the thermal currents we talked about earlier. Picture them as slices of toast floating on a layer of melted butter. When the butter moves, the toast dances along with it. This movement causes the plates to collide, drift apart, or slide past each other, and that's what triggers the earthquakes and volcanoes we see around us. For example, the Pacific Plate is moving under the North American Plate along the west coast of America, causing a lot of earthquakes in California. People there live on edge because of it. And in the Atlantic Ocean, the plates are drifting apart, so the ocean grows by about 2 to 5 centimeters every year. If you measured the distance between America and Africa now, and then again in a million years, you'd see a clear difference. But of course, it's slower than Cairo traffic in rush hour. Earth isn't just a planet. It's a living history book, telling its story through the movement of these plates. For example, about 50 million years ago, the Indian Plate crashed into the Eurasian Plate, and that collision was so powerful, it raised the Himalayas, the highest mountains in the world. Imagine two massive forces smashing into each other, and the result is mountains like that. If it weren't for this movement, there wouldn't be tall mountains or rivers like the Ganges, which gave rise to a great Indian civilization that's been around for thousands of years. Even dinosaurs were part of this story. When Pangaea started breaking apart about 200 million years ago, dinosaurs got spread across different continents. Each continent became like a big island on its own. which allowed new types of dinosaurs to evolve in different environments. So, if there hadn't been continental drift, we might not have had the incredible diversity of life that shaped the world as it is today. Earth is like a massive history book, with each plate as a chapter, and every collision or earthquake writing a new line in the story. Scientists read this book by studying rocks, fossils, and even the seismic waves from earthquakes happening every day. And the cool thing is, this movement is still happening right now. The continents are moving as we speak. Scientists say that in millions of years, the continents might come back together and form a new supercontinent called Pangaea Ultima. It's like they drifted apart, but they might hug again in the future. But that'll take so long that none of us will be around for the party. In the end, Earth isn't just a place we live on. It's a living story full of movement and change. Alfred Wegener, who people laughed at in his time, is now one of the most important scientists in geology history because he opened the door for us to understand this planet's tale. Today, we know that the continents we live on have a past full of adventures, a present that's moving, and a future hiding lots of surprises. Next time you look at a world map, remember it's not just a static drawing. It's moving right now as you're listening to me. Maybe super slowly, but it's moving, like a quiet dance that's been going on for millions of years. Thanks for watching this episode. If you liked it, don't forget to subscribe to the channel and hit the bell so you don't miss our new stuff. Peace out, and see you in the next adventure.